Okay, class, we're starting on section 6.4, factoring special forms. Now, it says objective 1, factor the difference of two squares. Now, we want to multiply this. So, we would take 2x times 2x, and then we would take our positive 2x and multiply it by the minus 5. We would take plus 5 times 2x and plus 5 times the negative 5. 2x times 2x is 4x squared. 2x times a negative 5 will give us a minus 10x. 5 times 2x is 10x. And 5 times a negative 5 will give us a minus 25. So now, we will have our 4x squared. Now we know negative 10x plus 10x gives us 0. Minus 25 will give us minus 25. Now, so if we see a perfect square minus another perfect square, 4x squared minus 25 is actually 2x plus 5 and 2x minus 5. Now, it says here the difference of two squares. What we would do is this here. If we have a perfect square minus a perfect square, we would take the square root of this first perfect square. The square root of a squared we know is a. So we would put a in both of these parentheses. Now, disregard the minus sign for now. The square root of b squared would just be b. Now, what goes in between these two values is a plus in one parenthesis and a minus in the other. It doesn't matter which one you have first or second. So it's a plus b times a minus b, or you could have a minus b times a plus b. Okay, now, let's go down here. First of all, let's determine if this is a perfect square. We know the square root, go off to the side here. The square root of x squared, we know is x, because x times x gives us x squared. Then we could take the square root of 9, which we know is 3. So those two are perfect squares, and they're subtracted from each other. So we do our two parentheses, and we'll write a plus in one, a minus in the other, and we'll take their square root. So we'll have x in both parentheses, and we will have 3 in both parentheses, and we're done. Now we come here. We can go off to the side. The square root of 4r squared. I hate when this happens with these 4s, but let me get this back going here. Okay, so we have the square root of 4r squared, which we know would give us 2r. And then we will have the square root of 81, which we know is 9. So this is the difference of two squares. So we would do our two parentheses. We have a minus in one and a plus in the other. Remember, it doesn't matter which one goes first. So we will have 2r in both parentheses. And then we will have 9 in both parentheses. And we're done. Now we scroll down here to the 36k squared minus 49. Now, the square root of 36, let's do these parentheses. Okay, the square root of 36k squared, we know the square root of 36 is 6, and the square root of k squared is k, which we could write here. Square root of 36k squared will give us 6k. And then the square root of 49, we know is 7. So we have the difference of two squares here. So what we would do next is this here. We will put it inside those parentheses. So we will have 6k plus 7 and 6k minus 7. And that is our final answer. Now we come here. Now we already know we did the square root of a 49 before, and we know the square root of x squared is x. Square root of 64 we know is 8, and the square root of y squared is y. So we know that these are the difference of two squares. So we will have 7x minus 8y and 7x plus 8y. Now we come down here to e. Now we know 25 is a perfect square, x squared is a perfect square, and 16 is a perfect square. So we know in one of our parentheses we have 5x minus 4. In the other parenthesis we have 5x plus 4. Now we come to f. Now this time we have the addition of two squares. There is no addition of two squares, so the factorization of n squared plus 9 would just be prime, because there's nothing more we could do with that. And what you could write down here for note, you could write down that there is no addition of squares. Now I typed this in here for you to write it down. There is no rule for the addition of two squares. So you could just put that in your notes. Okay, now we come down here to this next problem. Example 3a. It says factor. Now we know 49 is a perfect square, x squared is a perfect square, and 16 is a perfect square. So we would do our two parentheses. So now this will give us 7x squared minus 4 and 7x squared plus 4. There's nothing more we could do with this, so we're done. Okay, now we look here, 2x cubed minus 72x. Now in previous lessons I told you all, before we do any type of factoring, we look to see if there's anything in common between the terms that we're given. We can factor out a 2x. And we'll be left with x squared minus 36. Now we know this is the difference of two squares. So we would do our two parentheses. Square root of x squared is x, plus in one, minus in the other. And the square root of 36 is 6. And we'll bring down our 2x we factored out. So we're done. Now we come here to c. Now x to the fourth is a perfect square, and 16 is also a perfect square. So we had a difference of two squares here. This will give us x squared minus 4, and this will give us x squared plus 4. Now if you notice here in this first parenthesis, isn't this still the difference of two squares? And since it is, we have to factor that out. So we would do two parentheses for that, and then we would write our last parenthesis as it was, the x squared plus 4. Square root of x squared is x, plus in one parenthesis, minus in the other, and we know the square root of 4 is 2. So we have x plus 2x minus 2 and x squared plus 4. And this is the final answer for this problem. Now we go here to D. X to the 6 is a perfect square and also 9. So we will have x cubed minus 3 and x cubed plus 3. And that is it. Now we scroll down here. It says factor perfect square trinomials. Now this process here. It said let a and b be real numbers, variables, or algebraic expressions. So we have a squared plus 2ab plus b squared, and that's equal to a plus b in parentheses squared. Now what you have to look at is this here. Now you notice we have all addition here, which this number 1 has. So what we would do is we would take the square root of the first term, which is x, the square root of the second term, which is 1, and square the parenthesis. Now this is a special case because remember, if we take this first term times this second term, we know that's 1 times 1, and then we would have to multiply that by 2 because those are the coefficients. So this is x plus 1 squared, and you could also determine that by multiplying x plus 1 times x plus 1. Now we look here at b. Now we have a perfect square here and a perfect square here. Now what we could do is we'll put this in parentheses squared. Now we know the square root of 25 is 5 and the square root of y squared is y. Now because this middle term is a minus, we'll put minus in this parenthesis. And we know the square root of 1 is just 1. So now our answer here would be 5y minus 1 squared. Now we're going to look here at C as well. Now if we look here at C, we have 16x squared minus 40xy plus 25y squared. They have nothing in common. But before we tackle C, let's look back up here at A. When we did the x squared plus 2x plus 1, we put this in a parenthesis as x plus 1. Now to prove that this is correct, we know that we would square the first term, that would give us x squared. We would square the second term, that would give us our last term, which is 1. Now to get this middle term, we would take x and 1, which would be 1x, and double it. So x times 1 is x, and 2 times that is 2x. Let's try it here. 5y squared will give you 25y squared. A minus 1 squared will give you positive 1. Now to get this middle term, 5y times a negative 1, which would be a negative 5y, and then we would double it, which would give us a negative 10y. Now we apply that down here. The square root of 4x squared is 4x, and the square root of 25y squared, remember, since this middle term is a minus, we'll make it minus 5y. And we should square this parenthesis. Now, to prove that it's correct, let's just square this. 4x squared, we know it's 16x squared. We know a minus 5y squared is 25y squared. Now to get this middle term, 4x times a negative 5y, we know it would be a negative 20xy. Well, I'll write it over here. 4x times a negative 5y. 4 times negative 5 is negative 20, and x times y is xy. Now we're supposed to take this value and multiply it by 2, and that will give us a negative 40xy, which is our middle term. So we did it correctly. Now it kind of disappeared here, but you can rewind it and it will come back up. But this is your final answer. Now, we're going to scroll down here to 6.5. It says, a general factoring strategy. Recognize the appropriate method for factoring a polynomial. A strategy for factoring a polynomial. If there is a common factor other than 1, factor out the GCF. Determine the number of terms in a polynomial and try factoring as follows. If there are 2 terms, can a binomial be factored as a difference of squares? Which you know a squared minus b squared. Now, if there are 3 terms, is a trinomial a perfect square trinomial? If so, factor by one of the following special forms. Now, with this a squared minus b squared, we know that would give us a minus b and also a plus b. Now here, in this parenthesis, we will have a plus b, and outside the parenthesis it will be squared. Now here, we have a. Since your middle term is negative, it'll be minus b, and then the parenthesis would be squared. So we had a plus b in parentheses squared, a minus b in parentheses squared. Now, it says if the trinomial is not a perfect square trinomial, try factoring by trial and error or grouping. What I taught you all in the class was grouping. I didn't do the trial and error. If there are 4 or more terms, try factoring by grouping. Check to see if any factors with more than 1 term in the factor polynomial can be factored further. If so, factor completely. Check by multiplying. Now we come down here to A. We have negative 7x squared plus 35x. We know their greatest common factor is negative 7. Well, actually negative 7x. And we're left with x minus 5 in parentheses. So we have negative 7x times the parenthesis x minus 5. And that is your final answer. Now with b, you notice that's the difference of 2 squares. So we have 5x minus 7 and 5x plus 7. And that's the final answer for b. Now with c, we have 4 terms. Let's try grouping. Now I would suggest that we take a quick look at this here, and actually we'll finish this up in the next video.